Okay, so welcome back to another video. So here today we have a little number theory problem that is to find all positive integers n such that n plus 7 divided by the square root of n minus 1 is an integer. So I'm just going to divulge into the main subject for a second and just talk about the numerator, for example. So if we were to say that n plus 1 is an integer and we want to find all positive integers n that satisfies that statement, obviously we would see that all positive integers n would work such that n plus 7 is an integer. But since we're also dealing with the square root of n minus 1, and that's on the denominator, so that arises with some sort of divisibility issue, since we need to show that this rational expression is an integer. So entailing that we have to be careful what choices of n being a positive integers that we'd want to choose from. But that's actually not that difficult to see that if we can just rewrite the following expression in a way that's easier to observe, in a way that we can actually find our choices for n, then it's just pretty much just smooth sailing from there. There's nothing much I want to add since I just gave away the main premise on how to approach this. So let's actually just jump right in. So since we have n plus 7 divided by square root of n minus 1, so what I can do for the numerator is I can actually rewrite that difference. So n plus 7 divided by square root of n minus 1, I can put that down as n subtract 1 and then add this with 8 divided by the square root of n minus 1. Then we can actually split this into two fractions. So we have n minus 1 divided by the square root of n minus 1. Add this with 8 divided by the square root of n minus 1. So now what we can do is, because since n, we can actually rewrite the n minus 1 in a way that it's inclusion with the radicals itself, but also in a way that it also shows that same equality from the numerator. So in other words, I can rewrite this as the square root of n minus 1 square divided by the square root of n minus 1, and add this with 8 divided by the square root of n minus 1. Okay, I just wanted to be cool here. I don't know why, just for the hell of it. But really, you can just actually just multiply the square root of n minus 1 to both the top and bottom, and notice that the square roots will cancel on the bottom, and then the n minus 1 will cancel each other out. And so we're just left with the square root of n minus 1, and then add this with 8 divided by the square root of n minus 1. And I'll set this equal to k, where k is our integer that we want to find. So let me just denote this right here, k being an integer. Okay, so this is what we have so far, so that's good. So we want to notice that since we want to find all positive integers n, there's something we need to pay a little attention to. If n is a positive integer for whatever we need to find, so this means that this is still considered a natural number, and then this has to be a natural number simply because for k is an integer and we're dealing with square roots being positive, so that means, in other words, a natural number plus a natural number has to be equal to a positive integer, with this little condition over here. So, but that's not really that difficult to see because, well, I say that mainly because square root of n minus 1, we know that's a natural number, but we don't really have to pay attention to that sense. Really, the issue arises, as I mentioned, the divisibility issue, because we have an 8 divided by the square root of n minus 1, and we need to find our choices for positive n such that whatever for n satisfying with our given, plugging this back in has to guarantee that it has to be a natural number, and hence with two sums of the natural numbers will give us, well, a natural number, but it's also, natural numbers are also known as positive integers as well, excluding the 0, depending on how you guys look at natural numbers. So really, we don't really need to pay attention to this, but really we just want to focus on this term right here. So not that difficult. So we have an 8 divided by the square root of n minus 1, and we know that that's guaranteed in order for k to be an integer from the left-hand side, then that means we would have to see that 8 divided by square root of n minus 1 has to be a natural number. But what you'll notice is that in order for this to be the case, we need to find some factors such that in order to find n, 8 divided by some n that we have to plug in will guarantee the natural number. So really, we just need to focus on just the denominator over here. So we have the square root of n minus 1 So if we think of factors for 8, obviously we have that there's four elements. So we have that the set, so this could be either 1, 2, 4, or 8. Well, and 8, because those are all the factors over here. So now let's actually do each element one by one. So we have square root of n minus 1 equal to 1. You'll solve for n. That's easily shown that this is actually just equal to 2. So next we have the square root of n subtract 1 is set that equal to 2. Solve for that, you'll get that n is equal to 5. Next we have the square root of n minus 1 equals 4. Then we see that this is just n is equal to 17. And then lastly we have 8. So square root of n minus 1 equals 8. Then we see that n is equal to 65. And so pretty much we're done. So we have our all our possible choices for n that satisfies the following, which is perfect. So we have n is equal to 2, n is equal to 5, n is equal to 17, and n is equal to 65. And so therefore we have that n can be either of the 4 elements. So we have 2, 5, 17, and then 65, and just like that we are done. And so you can actually plug in these 4 elements into, the following expression to see if you get an integer, which you do indeed. Simply, we see that if I just plug 2 for n, so that means 2 plus 7 is 9, then 2 minus 1 is 1, so obviously 9 divided by 1 is 9. Plug in 5, 5 plus 7 is 12, 5 minus 1 is 4, square root of that is 2, so 12 divided by 2 is 6. 17 plus 7 is 24, then 17 minus 1 is 16, so square root of that is 4. So we have 24 divided by 4 is 6, perfect. Then 65 plus 7, so that's 72. 65 minus 1 is 64, the square root of that is 8. And I should also mention that it's square root, so both is positive and negative, but that doesn't really matter since it has to be an integer, so you can also include the positive and the negative integers, but this satisfies the following anyway. So 65 plus 7, 72, and then 72 divided by 8, positive or negative 8, negative 9, positive 9. You can say the same thing for other here. Positive, negative 9. What did I see here? This is 12, and then so that's positive, negative 6, and 17 over here is positive or negative 6, and then over here this is positive and negative, positive or negative 9, right? Yeah. Okay. So yeah, these are the choices we have over here that actually satisfies the following. So there you have it. So yeah, that's pretty cool if you ask me.